This video will show you how to create a reliability project, so that you can analyze failure data and obtain actionable results about your system. By doing this, you will be able to forecast failures, assess the reliability of your system, and many other things, without the need to get any sort of complex training about statistics, probability, or any other topic. The explanation from this video begins after a Broadstat account has been created and a subscription plan has been selected, so you'll need to do that first before you can continue with this tutorial. Once logged in, you'll see that the button for creating a new project is present in almost any page, so don't worry about where to start. Here, we're seeing our Broadstat dashboard, from which we can see all our projects, manage our account and find all our saved articles from the content section. We're gonna click the New Project button to start our first project. Here, we're asked to fill in both the title and description of our project. For the title, try to use something that describes the system you are analyzing. If you expect to test different variations or revisions of the same system, make it clear in this field so that it's easy to differentiate which of the projects relates to what. For the description, we should use something that gives us sufficient information to completely define the system we are dealing with, and the conditions it's operated under. If a colleague of yours comes across this project, they should be capable of understanding which system you are referring to and other relevant parameters like firmware version, system revision, etc. When you click Create, you're taken to the project planning section of your project, where you can add a couple of optional extra details about it. The most important one of them is the failure definition field, as it helps to ensure there is a common agreement between you and your colleagues about when a system is considered to have failed. After you've finished completing the details that you consider necessary, you can click Continue to move on to the next section. The data input section is the one in which you add all your failure and suspension values, so that they can be used to calculate your system's reliability. These values can be obtained from two different sources. The first one is information you have collected from real-life usage that resulted in one specific failure mode, and that has been reported by your clients or by service engineers. The other way of obtaining this failure data is by setting up an experiment in your lab, and cycling a set of units of your system or subsystem until they fail with the failure mode you're analyzing. You can select between adding exact failure data or interval failure data by clicking on the last checked switch. Exact failure data is used when you are certain about the time of failure of your samples, while interval failure data derives from not knowing the exact failure time, and instead knowing the interval of time in which it happened. The latter is common when you check a test periodically and discover a new failure, which you know happened between the time of detection and the last time it was checked. You can also introduce suspensions by clicking the FS switch. Suspensions are samples that have run through a number of test cycles but have been removed from the test before they've reached their failure point, either because the test had to finish early or because those samples were needed somewhere else. In this example, we've made up some data, representing a test that's checked every 5 hours, so for each sample we have a failure time, and a last checked value 5 hours before it, at which time we know it was still functioning. We've also added two suspensions towards the end of the test from a couple of samples that didn't reach their failure points by the time we had to use them for other purposes. Once you've introduced all your data, you can continue to the next section to automatically calculate the results of your project. The first thing you'll see in the results section is the different graphs displaying probability curves about your system's reliability. The probability density function, in green, shows the probability of failure for each moment in time. It gives you a glimpse of where the maximum concentration of failure probability is and a perspective of the time scale of your system's reliability. The unreliability function, in yellow, shows the accumulated failure probability over time. It starts at 0, and reaches up to 1, or 100% probability of failure. And finally, the reliability function, in purple, is the inverse of the unreliability. It shows the accumulated probability of survival, and goes from 1 to 0. In the right panel of your results sections, you'll find different information about the probability distribution obtained by fitting your data, like the type of distribution, its defining parameters, how well does the data match with it, etc. You can also select the degree of certainty you want for your results, and display the confidence bounds for both the unreliability and reliability graphs. These bounds will show you the intervals within which you can expect your results to be, which can be considered conservative and optimistic scenarios of your results. Two factors affect the width of this confidence interval: the degree of certainty you select and the number of failures you add to your data. The more data you add, the more precise your results will be. You can also request human-friendly questions to your project results by adding highlight data points. When you click on the Add button, you can fill in different question requests like, what percentage of a population of devices is expected to fail before reaching a certain amount of hours, or what's the probability of failure of a device after functioning a given amount of cycles. If we add a couple to our project, you'll see that they are added to the right panel, but also to the corresponding graph and the interpretation area. The interpretation area gives you a bit of background about the type of distribution your system follows, as well as how well your data fits it, but also may include tips to improve your test, in case your data seems poorly fitted. At the end of the section, it displays human-readable translation for all the highlight data points you have requested, making them easy to understand and share with your colleagues. If after watching this video you still need a bit of guidance, don't forget to visit our blog and knowledge pages for more information. You can also send us an email at the address in the video description and we'll do our best to assist you.